Now I am.
Okay.
So, of course, you have our machine tree over here on the left-hand side. We're doing the finish mill area. And we basically, when I do analysis, I have these four plots open, two waveform plots and two spectral plots. This first waveform plot is basically a history. So January, October, July, so when this data was taken. Kind of see how it changes there. I'm looking at the horizontal reading only off of the triaxial transducer. And then same thing down here, only in the spectral domain. I'll usually, set that around 2000 hertz is my F max. And then, of course, that's how it kind of rings out there. Over here on the right-hand side, this is where the real significant thing comes in. I've got another waveform plot. Just selected the waveform plot right here to create that. And what I've done is rather than do the horizontal vertical axial, I've told it to show me the high one of the horizontal vertical and axial. So it'll show me the worst case scenario waveform plot in this upper right hand corner. And I mostly just keep an eye on that to see what the peak to peak value of the waveform is.
That's something I've been noticing a lot lately. On Syntec air compressors and gearbox, that 3Gs plus and minus just does not apply.
Well, but you just figure out what does. I mean, 3Gs for a standard machine. Syntec doesn't fall in a standard machine. Yep. But it gives you an idea of where it's at, and so you can say, well, if my number's 12, then I start to be concerned, then I'll just look for 12 over there.
Well, that's kind of what I've been zeroing in on, is 12 to 15 Gs on those.
Well, and that's fine, but it just gives you the highest value of the horizontal, vertical, or axial to take a look at and just kind of keep an eye on.
Yeah.
This one down here, I typically leave it full frequency range, so I pull all the way over and see it typically out to 8,000 RPM or 8,000 hertz, and I make this selection here. Rather than selecting horizontal, vertical, and axial, I do a peak hold.
And that pulls up the highest one in the sample?
Well, it takes all three samples, overlays them, and gives you the highest peak at each frequency, regardless of which sample it came from.
Okay.
And that's a peak hold. So over on the right-hand side here, I've got the worst case out of those three pieces of data. On the left-hand plots, I get a little bit of history from those guys.
All right.
In this case, it's basically 6 months of history because we go out there once every 3 months.
Looks like they did something to it between the first and second one.
Possibly, or just differences in load or temperature or whatever. So where it's still, less than 2 Gs, it becomes a who cares, and we just, even though there's a little bit of difference there, we just keep going forward.
All right.
And so once I've got that set up, those are the four plots I typically use. And I just walk through these. And as I look at the waveforms, that's where I always start looking first. There's basically three things I look at. One, what is the amplitude? Two, is there a pattern?
Yeah.
Okay. And then three, is there anything I want to play over the speakers? And I can do that by doing this. Kind of noisy.
Yeah.
And that actually sounds not so good.
Oh, no. That sounds absolutely normal for a Fuller Cavaco air pump.
Yeah, it could very well be. The other thing I tend to do is I tend to turn this filter on right here. So what that does is it takes this number, 2000 hertz Fmax off my spectrum, and it filters this data to the same frequency content as my spectrum is.
So that's like a low pass filter, everything below 2000 hertz?
Yeah, unless I do something like this and make it a bandpass filter.
Ah, I like that.
Is that cool or what?
Now, where did you do that at again, where the blue line is?
Okay. This bottom portion of the spectrum, if I divide it in half, if I roll the mouse wheel on this side, it changes the Fmax number.
Uh-huh.
If I go to the left half and roll the mouse wheel, it changes the Fmin number.
Ah.
If I come up on the plot, then the mouse wheel changes the amplitude of the plot.
All right. Those are some powerful little deals right there.
Yeah.
But I really like the way you do that filter.
Yeah, it's cool when I do it. But we've got this long time waveform that's 8 seconds long, so we can do that. If we had just, 2,000 data points like CSI lets you have, you can't filter it.
Yeah.
But the fact that it is 8 seconds long, we can filter it. Okay? So I usually use filter on. If I want to listen to the vibration, I click the little play button here.
Now, will that play the filtered signal as well as the full signal?
Yes.
Okay.
So if I play it now, remember it was really noisy before?
Yes.
Listen to this. It takes a lot of that snapping, popping sound out because we filtered it.
Yeah.
Okay, so
that 4-cavato pump has sliding vanes in an eccentric barrel.
Yep.
And they really kick off the high frequency vibration.
Yep. So if I turn the filter off and play it, it does certainly sound like we've done filtering, does it not?
Yeah. Okay.
Okay.
Well, you just answered 2 or 3 of the big questions I had. How do you filter and stuff like that?
Yep. The other thing I tend to do is I'll tend to shorten this time window down. It gives me a 2-second window.
Uh-huh.
And I've got 2 different ways to choose that. I can choose it around the cursor, or I can have it choose it around the highest peak in the most current data.
Huh.
And so I typically choose the highest peak or in the current data, and it always shows me the highest amplitude here.
Yeah.
And it cuts it down to a 2-second window versus the 8-second window. However, if I do hit the play button, it still plays the full 8 seconds.
Uh-huh.
And then you can see the cursor go across when it plays that one, so the portion that we're looking at.
And you have to let it play the whole 8 seconds, right?
Yeah, there's not any way to shut the thing off that I've been able to program yet, so.
We can live with that.
Yeah, it's not too bad to live with it. If I want to play the unfiltered sound, I can click on here, or I can turn the filter off and click on this one.
Uh-huh. And that plays the most recent data?
Yeah, it plays essentially the one on the top here, or the one that's being displayed over on the right-hand side here.
Yeah.
I can kind of step back through time. If I click older, and I click older, you'll notice that this October 1st jumps up here to the top.
Okay.
And we should start dropping off of this guy. Yeah. Or I can step back through it, or I can go all the way to current. So these guys just let me manipulate which one is the current data here.
All right.
But whatever one's right here on the top is the one that I'm going to play, so I can effectively play my old stuff as I go through that as well.
Huh.
Okay, so I'm just going to go through some data here. And that one was really high back in July. It gets better the longer they run it here. Huh? What I find on these FK pumps is the bearings do tend to show up, even though you've got all this other stuff going on. The bearing defects do tend to show up.
Well, I think I know why. Those are very, very hefty roller bearings, and the weight of that rotor just doesn't support the need for that bearing, I don't think.
Okay. Okay, we got a little bit going on this particular guy. This is FK compressor. And you say, well, it's an FK compressor, so I'm probably just going to let this one go. My highest amplitude in the spectrum in the right hand, lower right hand here is about 0.1.
Yeah.
And that frequency is at about 80 hertz, it looks like. So it's probably a vein pass frequency of some sort, which is very typical on those guys.
Yeah, I think there's 6 veins in there, if I remember right.
Yeah, that sounds about right. And they typically run 1200 RPM.
Yeah.
Yep, so I typically just say, look at the compressor stuff. Is it changing? Is it not? And I move on. I'm going to skip this machine. Notice that it's April is the only data that's there.
Uh-huh.
I can just pick it off the list here. And just go on through these guys. 2 Gs, less than 2. There's 4 Gs. Really not any changes. There's 4.5. Just go on through. Got a compressor again. So this guy should jump up. Yes, it does. It's up a little bit from where it has been, but we just tend to go watch those guys. 2 Gs. There's 8 Gs. That one's kind of interesting, but only over on the right-hand side it's 1.5. So I'll go ahead and skip that.
This brings up an interesting technique that I tried when I was doing a cement plant on those Explorer Cavaco machines.
Uh-huh.
I would put a piece of cloth between the magnet and the bearing housing, and that would effectively filter out all of the high frequency data.
Interesting.
With CSI, that just did an overload on the system and you couldn't measure
it. I wonder if you'd try such things, huh? Well, this compressor's come pretty close to hitting the upper end here of our transducer range, because our transducer range is plus or minus about 55 Gs before it overloads.
Do you know what the plus or minus is on that 10 millivolt sensor?
Yeah, 500.
Yeah. But I measured 660 Gs one time in peak view.
Yeah. Nothing there. A standard blower. Nothing there. Another blower. Nothing there. Finish mill. A little bit of bearing noise showing up here in the spectrum, but the amplitudes aren't terribly high. 0.06. I'm starting to get a little bit of stuff around that one.
Yep. Looks like it's getting worse.
This is one that they actually had the bearings start to overheat on them, so they got a look at them, decided that the inside of the bearing was rotating on the shaft. They sent the pinion shaft out and had the bearing surfaces redone and put a new set of bearings back on it between the yellow data and the red data.
Interesting. Nothing really high.
No. But it, down here from the 1st of October had some stuff showing up. So this one ended up on our report just because of the pattern that was there.
Uh-huh.
And then here's the little guy. Yeah, that's kind of interesting. The peak there is at about gear mesh frequency. A little bit coming up. Oh, notice we've got a 0.24 inches per second. We can see a significant increases there. So let's go find out where that other one's coming from. Not vertical. That'll be axial. Yeah, there it is.
Wow.
Yes, this one is going to be gear mesh. Gear mesh on this guy is just under 60 hertz.
We've got, well, they've got a ball mill out at the slag mill. It's got some gear mesh and bearing faults going on at 0.7.
Wow, yeah. Well, I think I'm going to write this one up just because I'm seeing that gear mesh. Got our harmonic here, so we get our second harmonic to gear mesh, but then we've got something else here that's unrelated. It's probably, it about has to be bearing defect. That's about all it can be.
Yeah, I think I would agree with that.
Let's see what this one looks like.
Not very high amplitude, but it's not very high speed either. And that pattern is really messy.
Yeah.
Truncated on the plus side.
Yeah. And, you know, you look at this one and it's significantly different from going back to these ones from October. There's a few more plots there. Let's see what it looks like. The fourth plot. Yeah. Yeah, you can see some history there that's certainly changed. So, do we show them this plot? Yep. That's the one we show them. That's the held bearing, so you'd expect the axials to potentially be a little higher. So when I write a report here, you're going to like this, Carl. Click on this little clipboard. I'm going to call it a priority 2. And I'm just going to call it the pinion shaft coupling side. And we can type in here or we can pick it off a list so we don't have to retype it. Something like that. So what do we tell them? I don't like that per se, so we'll just say something else here. And so, anything else we want to say about this guy? Tell him what to do here. Check the temperature profile.
Doesn't that truncated pattern at the top indicate looseness?
Yeah, it shows a little bit of looseness. The 2 times the gear mesh can kind of hint that there's some looseness. The other side of it is on a, this is a, just like your ball mill out of the slag plant.
Yeah.
It just has a, you know, a pinion driving a ring gear, so you expect to have a little looseness in the rattling of the balls and so forth. So I typically don't talk about looseness on these things because of that.
All right. And they probably wouldn't do anything about it anyway.
Well, they're concerned about it, but so I've just done these guys. I can do a little spell check here if I'm worried about my spelling. It looks at that whole first paragraph or sentence. Didn't find anything wrong there. This one has got bearing gear. I'm going to just go ahead and skip that one if you want to keep it. Continue. And gear mesh, we're going to skip that one as well. I don't have to do that. I can just run it through the spell checker if I'm a little concerned about things. So
yeah.
So I hit save at this point, and I just go back to analyzing now. So this is where I put in all of my stuff I'm going to write up for the report.
Okay.
That's a little easier than cutting and pasting, I think.
Yeah, it is.
So we'll just go on through the rest of this department here and see if anything else jumps out. I keep an eye on it here because some of these machines don't run. Okay. There's got a little bit of hit going on, some pattern, but the amplitude is low. That's a little higher. Certainly changed since April. And I would guess that this has the potential to be caused by a coupling, would be my guess. The non-drive end has got that pattern there, but it's low. This isn't terribly high, it's 2.27, but it has certainly changed since the last time. If we look at this guy, it's showing all mechanical looseness, but something has changed significantly here in this waveform plot. So if I want the waveform plot to be included on my report, then I hit this generate report button off the waveform plot before I did it off the spectrum plot. So I'll just go ahead and hit here. I'm going to call it a priority 3. And we're going to call this a possible coupling defect on the gearbox input shaft.
Is there any way you can tell what the time period between those peaks is?
Yeah, I'll come back and I'll show that to you. Deficiency, yes. Who knows? We'll run the spell check there. And recheck the vibration next time. Characteristics. CH.
That's the right spelling right there.
Right where?
Put an A right there.
Yep. I don't know, is it?
Yeah, that's the right spelling.
Any deficiencies? I have to find another word if I can't find out how to spell it right. Okay. And it puts that word in there once I click on it. Skip that one. Says we're done. Okay, and then it's updated that here. So that's how we use the spell checker program. So I hit save here. So if I do that, stretch this guy out to where it hits the peak here, something like that. Tells me it's about 15 hertz is the frequency there.
How many hertz does the shaft turn?
Good question. That's 900 RPM. That could very well be a 1 times there.
Yeah. That's a very good choice for a, oh, that's a belt conveyor?
Well, it's a belt conveyor, but it's driven through a gearbox.
Right.
So it's a motor driving a gearbox.
And that's on the motor in the axial position?
Yeah, that's the axial position. Yep.
So I noticed that you just aren't seeking after all that much accuracy. You get close to a frequency in that time waveform.
Yeah,
I would sit there and fiddle with it till I nailed it.
yeah, but you get out here and you say, well, if it's a 900 RPM shaft.
Yeah, and that's close to 900 RPM. So
Yeah.
Okay.
We can fiddle around all we want, or we can, it doesn't change our analysis. In all likelihood, this is a coupling issue.
Uh-huh.
And have them go out and check that. The amplitudes aren't terribly high. If they can repair a coupling at this point, that's a good choice.
Yep.
And if the coupling's fine, then we'll take some data next time and look for more changes. So I'm going to go merrily upon my way here.
Yep.
Belt.
See, my problem is I did those Syntac air compressors, and they wanted a lot of accuracy on it, and it takes a lot of time, so I really picked stuff apart.
Well, and that's not necessarily a bad thing, because the Syntac air compressor is a whole different animal than a little simple belt conveyor gearbox.
Yep, from initiation of a significant fault to wreck just isn't very long.
Yep. So you need to know where each one of those peaks in that spectrum belongs at.
Yeah, and there's a lot of them.
Yeah.
I mean, on these 4C compressors Scott's sending me data on, there's the bull gear and 4 separate rotors in that compressor.
Wow.
So you got 5 different shaft speeds to look at.
Wow. I'm skipping these because this is October data on that one.
Oh, bucket elevators. I love those.
I'm sure you do. They're almost as much fun as a screw compressor.
I got a picture of a screw compressor I need to send you.
Yeah.
You could bury 4 guys inside that housing.
Wow.
It's a big gas compressor.
Uh-huh. And so I'm basically going through this by the amplitude and the waveform. And as long as it stays below that 3 Gs, I just keep moving here.
That's probably a really good way to do that.
Otherwise, you'd spend too much time doing analysis.
Look at that one.
Yeah, from back in October.
Wow.
Wonder what that one is. Let's pull him up here where he's the top one.
Can you do a circular plot with that?
I don't do circular plots yet. That would be cool, though. That's all multiples of running speed.
Wow, that time waveform in the right plot was really weird looking.
Yeah, it's just spread out more. It's 1 second over here. This is going to be one that's Vertical goes the opposite direction. That's kind of interesting. There's that highest reading there. That's back from October, so whatever was going on isn't anymore for whatever reason. So we move on. Okay, we've got a TGs there. Horizontal is the highest. Get back to my history plots here. No history on this guy, just got him this time. And once again, it's a compressor, so if it's a compressor, you start saying, well, I'm going to be a lot more forgiving on what it's doing.
Is it a screw compressor?
No, it's one of those next to an FK pump, I believe.
Okay.
So they're not seeing the FK pumps. Where are they at? What kind of compressors are they? But the amplitudes are pretty low, so I just go on. These dust collector fans are just kind of standard little fans. Some are overhung, some are center hung squirrel cage. But once again, we're looking at that, 3G's number, just kind of cranking them through here. No, there's October. There's a January one. That's interesting. Why is it showing up at 47 G's here?
These plots on the right,
Uh-huh.
is that the highest one or the most recent one?
No, it's the highest one.
Okay, and how do you make it pull that up?
It's looking at the horizontal, vertical, and axial off the triaxial transducer.
Uh-huh.
And it's looking at all of those, and whichever one has the highest peak, that's what it shows here.
Okay. But how do you pull it up to make it do that plot? What do you click on?
Oh, you just select another waveform plot. Then you set this one to high.
All right. So you can get multiple plots out of this.
Yeah. That's plus or minus 4 G's. A little bit going on there, but not much. It's kind of being about the same over the last 3 months here, or last 6 months. So I'm going to go on. Just running my mouse wheel to pull that up there. 1 G, 2 G's.
I'm not going to have the benefit of historical data on this stuff Scott's sending me.
Yeah, but down the road you will. So you just end up setting those up as single plots is how you do those initially. You have to do a little more analysis when you just have a single data plot. Because if the vibration's not changing, then it becomes a who cares. So I'm a little bit concerned on this one. See, I've got that peak that's coming above 0.1 there. I've got
a lot of
too. I've got one at 0.36. So I wonder which one that is. Probably the axial again. Yeah, there it is right there. And that shows some pretty good history there. Let's pick up that fourth plot.
Not really.
It's going right back where it was. See, it looks like it got repaired between this one, between May and July. And now it's kind of working back that way.
Yeah.
That's about 120 hertz, it looks like. Let's see how close to 120 it really is. Just under 120. So that's pretty close to 120 though, so that very well could be electrical.
Yeah, but that's in the fan bearing, not the motor.
It is on the fan bearing. Yeah, good point. Well, that looks to me like it's going back to where it was when they repaired it. So what I'm going to do, just for presentation purposes, I'm going to do that plot right there. Click on our clipboard. I'm just going to call this an alarm. All it can be is a bearing defect on the fan shaft. So we're increasing that in the defect characteristics. Fan bearing should be replaced in between 190 days. That's pretty easy right up there, wouldn't you say?
Yeah, but you got bearings misspelled.
Well, you are correct.
Sometimes I do that.
We'll see if it can find it. Oh, I got characteristics misspelled again. D-E-E. There it is right there. If you know which word is misspelled, you can usually figure it out, you know?
Uh-huh.
Okay, so moving on. Drop back my horizontal rating here. There's 4 G's on that guy. Going to move on. It hasn't changed. Well, look at that. We've got 0.25, 30 hertz. So that's 1 times on the motor.
This is belt drive.
Yes.
Okay. That other peak's probably your fan RPM.
Yep. Well, I'm probably gonna, man, that's just on the edge. But you know, what do you do with the motor that's got a higher vibration other than to watch the thing? You're not gonna go balance the motor. Probably just need to clean some dirt off the pulley.
I would also tell them to check the belt pulleys for run out and alignment, because you got both frequencies in both machines.
Yeah. More so on the motor though.
Yeah.
And,
Check for a soft foot on the motor too.
like that?
Check for a soft foot on the motor.
Yeah.
Or it can respond more to that pulley run out.
Yeah. And this place, they're grinding cement into powder. And so there's cement dust everywhere.
I've been there.
Yeah. I think I'm going to leave that one, because it'll probably last longer than the bearings will.
I spent the best part of my life at Roanoke Cement.
Oh, did you?
Yeah. I was making almost $50,000 a year off of them.
Wow. It's got a little kick going on that motor.
Yeah.
But not a lot of change. Look at these bearing patterns out here. They're coming up a little bit, but we're still well below 0.1.
Change that to acceleration.
Which one here?
Yeah.
Okay.
Rotobar passed.
I think so. Except they're on the fan.
Well, that's true. Yeah, probably a bearing.
Yep, and I'm going to let it go another month here. for another 3 months, mostly because it's not changing very fast.
Right.
There's certainly a defect there, but it's not changing.
Oh, hello.
That had something going on there, didn't it?
One thing that bothers me with that, and I think I know why, is your FFT and time waveform don't seem to agree all that much. So your time waveform in the red shows a lot of impacting.
Yeah.
But you're not seeing it much in the FFT.
Yeah, but look at the amplitude in that FFT.
Yeah. Uh-huh.
Uh-huh. And it's not just unbalanced.
Yeah, because your 2 times is more than 50% of the 1X.
Yeah, and it's a belt-driven fan.
Huh.
Which means you've got some mechanical looseness in that bearing.
I would say that just from the time waveform.
Yeah. I'm going to stretch this out a little more so it can be seen. There's nothing above 500 hertz. If I look over there on the right-hand side, the right-hand plot, over here,
Yeah.
there's nothing above 500 hertz. So, I'm going to call this severe mechanical looseness. Inspect everything, right?
Yeah.
Look at that one. There's my report from last time. Kind of cool how that just shows up there if you've got already written report last time on there, huh?
Yep.
Okay. I'm just going to leave the rest of it the way it is. Yep, that's a bad boy. Here's the thought. Not only 2 data plots.
Play that time waveform sound.
This one right here.
Yeah.
Let me get the worst one. I think it's that one.
Did you run?
Yeah,
1.6 inches?
it's not big enough to run too far, so. That's with the filter off. There's the filter on. So we wrote that one up. Okay, skip this one, it's October data. Look at that one over on the right hand side. There that one is. Okay, let's get 4 plots up. And then we want to press down the shift key and roll the mouse wheel once, come back in here, hit about 3,000. That's where you're starting to get the noise come up. So what's going on here? If we filter it to 2,000 hertz, we still have that pattern pretty well there, don't we? But it gets more pronounced in higher amplitude. We go to 3,000 hertz. So. Okay, so I'm gonna that's the one I want to show them, I think. That shows some change since July, doesn't it?
Yeah, quite a bit.
Yeah. Priority 3. You know, if this is above 10, we'd probably go to priority 2. Bearing defect on the motor shaft. Call it drive end. Defect characteristics. The motor here. Maybe we'll leave it at 90 days. Yep. Bucket elevator. Non-noisy machines anyway. Huh? Oh,
Yeah.
Yeah, that sounds like an unbalance. That's at 60 hertz. Oh, that's from July. We don't have to look at it. I can move on. Yeah, so the last time I took data on that was in July. So that one got better. See if it moved. No, didn't move there. That one got lots better since July.
Yeah, but why?
I know, you have to call them up and ask them. And they probably don't care if it's not any better, and that's an October reading. So now we've gone through all the machines in this department. Click on the report button. Put in the, this is just new feature. Oh yeah, that's true. Put the right company in here.
Now, are you with IVC Services?
And that's where we do most of our services through is IVC Services. Our maintenance technology is where we sell equipment.
Because I've seen some jobs open for IVC.
There's an IVC in Ohio, not to be confused with me.
Okay. Glad to hear that.
Yeah. So we put this information in, we click on Generate Report. It asks us where we want to store this guy. And it's ready. It's finish mills. Let's put into date this month. And hit OK. Then it goes and collects all that information and puts it into a report. So if we go pull this guy up now, we can show you the report we actually created.
Send me this recording, and I'm going to go ahead and start putting together a workflow for this. And we're going to start working on a workflow for working with the V-Box.
Okay. Guess what? With my new install here, I don't have my PDF reader installed yet. So, so everything but show you the PDF file when we're done here.
Chrome does it.
What's that?
He said Chrome will do a PDF install.
Yep, that's where it's doing. It's downloading Google Chrome and Acrobat Reader. I'm not sure I want Google Chrome. I was going to see if I could live life without it. Well, maybe I'll go ahead and stop the recording.